Hello, good day viewers. We have four functions here that we want to integrate one at a time. So let's get started. All right, here is what we want to integrate. This function will be much harder to integrate because of this square root. Therefore, let us simplify the radicand a little bit by multiplying the top and the bottom by x minus 1. So let's do that. It will not change anything. So this is the integral of the square root of x minus 1 multiplied by x minus 1. You do the same thing to the bottom. We have x plus 1 multiplied by x minus 1 with respect to x. To the top, you can see x minus 1 times x minus 1 is the same thing as x minus 1 all squared. So this is equal to the integral of the square root of x minus 1 all squared divided by, you can see this is just difference of two squares. We take the first term, we square that, we subtract the second term squared. 1 squared is 1 dx. So to the top, 2 will cancel the square root. So this is what we have, the integral of x minus 1 divided by the square root of what? X squared minus 1 with respect to x. Now we can split the fractions. So this is equal to the integral of the first term, which is x, divided by the square root of x squared minus 1. Then we have minus 1 divided by the square root of x squared minus 1 with respect to x. So now we can integrate these two functions separately. So this is equal to the integral of x divided by the square root of x squared minus 1. Then we have dx minus the integral of 1 divided by the square root of x squared minus 1 dx. The second one is very simple because we have an identity for that. So let me evaluate this before coming back to this one. We have an identity that stated that if you want to integrate a function 1 divided by the square root of x squared minus e squared, for which a is constant with respect to x, this is the same thing as the natural log of the absolute value of x plus the square root of x squared minus e squared plus the constant of integration. So we can apply the same thing in integrating this one. Therefore, to integrate 1 divided by the square root of x squared minus 1, this is the same thing as the natural log of the absolute value of x plus the square root of x squared minus e squared, but e is 1, which is 1 squared, and 1 squared is 1, plus the constant of integration, but we can leave it for now because we are not done yet. Let us come back to this one. So this is what we need to integrate before we join it with the other one. We can let u to be equal to the radicand here, x squared minus 1, x squared minus 1. Let us differentiate both sides. We have du over dx equal to, differentiate x squared, you get 2x. Differentiate negative 1, you get 0. Divide both sides by 2 and multiply both sides by dx. It's like switching 2 and dx. So you have 1 divided by 2 du equal to what? X dx. Already we have x dx here, which we can now replace with 1 over 2 du, right? So let's do that. We have our integral to be 1 divided by 2 du to the top, divided by the square root of u, because we have let x squared minus 1 to be equal to u. 1 over 2 is constant, so we can bring it out. So we have 1 over 2 outside. Inside, we have 1 divided by u to the power of 1 divided by 2, which is the same thing as the square root of u, du. All right, this is equal to 1 divided by 2, the integral of u raised to the power of negative 1 divided by 2, right? Du. So we add 1 to the power and we divide by the result. So this is equal to 1 divided by 2 multiplied by, if you add 1 to negative 1 over 2, you're going to obtain 1 over 2. And we're going to divide by 1 over 2, right? Such that this 1 over 2 will cancel this 1 over 2. What we have is equal to u raised to the power of 1 over 2, which is the same thing as just the square root of u. But what is u? U is x squared minus 1. Therefore, this is just equal to the square root of x squared minus 1. So we have obtained the integral of what? X divided by the square root of x squared minus 1 dx. And we have the other one, so we can now join them together. Let me bring them together. The integral of 1 divided by the square root of x squared minus 1 dx is now equal to the natural log of x minus the square root of x squared minus 1. But remember that this minus this is the same thing as what we have started with, right? Which is what? The integral of the square root of x minus 1 divided by x plus 1 dx, right? Which is just equal to, we have this minus this, the square root of x squared minus 1, then minus the natural log of the absolute value of x plus the square root of x squared minus 1, plus the constant of integration, and we are done. So here is our function. We want to integrate 1 divided by x multiplied by the square root of x squared plus 4. This is famous. Remember, if you have square root of x squared plus a squared, you can always substitute x with 2 tangent of theta, right? So we are going to make a kind of substitution here by letting x equal to 2 tangent theta. So wherever we have x here, we are going to replace it with 2 tangent theta. But let us differentiate both sides. If you differentiate this, you have dx. So we have dx here. If you differentiate this, you know 2 is constant, but the derivative of tan theta is what? Secant squared theta. So now let us back substitute. So our integral become the integral of, to the top, we have 1 dx, but dx is what? 2 secant squared theta. Okay, we have d theta here, right? So we are going to replace it with what? 2 secant squared theta d theta. Then we divide by x, which is 2 tan theta, 2 tan theta, multiply by the square root of what? X squared plus 4. But since this is x, we're going to square it before we add 4. That's going to give us 4 tan squared theta. So we have 4 tan squared theta, then plus 4. We have 4 here in common, so let's factor 4. This is equal to the integral of 2 secant squared theta divided by 2 tan theta multiplied by the square root of 4 multiplied by tan squared theta plus 1, right? Then we have our d theta here. This is equal to the integral of 2 secant squared theta divided by 2 tan theta multiplied by the square root of 4 multiplied by tan squared theta plus 1 is secant squared theta. So we have secant squared theta. Remember, we have d theta here. All right. Square root of 4 is 2. Square root of secant squared theta is going to give us secant theta, right? So this is equal to the integral of 2 secant squared theta divided by 2 tan theta multiplied by 2 secant theta d theta. From the top to bottom, we have secant theta in common. So let us cancel 1. So to the top, we are going to be left with only 2 secant theta. To the bottom, We have 2 times 2, which is 4. Then we have tan theta. Because secant theta has cancelled, we have d theta here. 2 over 4 is 1 over 2, and it is constant. We can bring it out. So this is equal to 1 divided by 2 multiplied by the integral of secant theta divided by tangent theta d theta. Secant theta divided by tan theta is cosecant theta, but let me show you how before I come back. If you have secant theta divided by tan theta, you should know that secant theta is 1 over cos theta. So this is 1 divided by cos theta. We divide it by tan theta, which is sine theta divided by cos theta. You can see that this will cancel this. We have 1 divided by sine theta, which is equal to cosecant theta, right? Therefore, the whole of that function will be cosecant theta. So this is equal to 1 divided by 2, the integral of cosecant theta d theta. You know that to integrate cosecant theta, we have a formula for that, which is equal to what? Remember, we have our constant, 1 divided by 2. Then we're going to multiply that by the natural log of what? The absolute value of cosecant theta, then minus cotangent of theta. Remember to add the constant of integration. We are done, but remember that our function was in terms of x, not in terms of theta. So how can we bring it back? Remember that we have substituted x with 2 tangent of theta. So let me just copy that. So if x is equal to this, we can divide both sides by 2. We have tangent theta to be equal to x divided by 2, right? And theta will be tan inverse of x divided by 2. Therefore, theta is equal to tan inverse of x divided by 2. Therefore, wherever we have theta in that our solution, we are going to replace it with tan inverse of x divided by 2. All right. So finally, our solution is 1 divided by 2 multiplied by the natural log of the absolute value of cosecant tan inverse or arctangent of x divided by 2. Then we minus cotangent of tan inverse of x divided by 2, right? Then plus the constant of integration. And hence, this is the solution to that problem. Here is our second to the last problem. We are going to integrate this function 5x plus 1 divided by 2x squared plus 4x plus 3 with respect to x. One thing you should observe here is that if you differentiate the denominator, you're going to obtain 4x plus 4. So how can we transform our numerator in such a way it will contain 4x plus 4? That's our main goal. Our numerator is 5x plus 1, right? And I know I can write this as 5x plus 5. What have I added? I have just added 4 because this is 1 and this is 5. So to compensate, I'm going to subtract 4. 5 minus 4 is 1. So let me group the first two terms. We have 5 in common. So I can say that this is equal to 5 outside, inside. I have x plus 1, right? Then I still have minus 4. Still, I want to transform it into 4x plus 4. So by multiplying these two times by 4, they will become 4x plus 4, right? So I have 5 multiplied by 4x plus 4, right? Then minus 4. I have multiplied by 4. Therefore, to compensate, I'm going to divide by 4, right? So divide the whole of this by 4. Now our original numerator has been transformed into a term that contains 4x plus 4. So let me replace our numerator with this. So therefore we have the integral of, I can now even write it as 5 over 4 multiplied by 4x plus 4, right? Then minus 4. Our denominator is still 2x squared plus 4x plus 3. 2x squared plus 4x plus 3 with respect to x. Now let us split this fraction because we have 2 times here. So this is the same thing. I can bring 5 over 4 outside because it is a constant, multiplied by the integral of 4x plus 4, right? We divided by the whole of 2x squared plus 4x plus 3 with respect to x. Then I will take the other one, minus 4, right? Multiplied by the integral of 1, because I have just factored out 4, divided by 2x squared plus 4x plus 3 with respect to x. So this is what we have to integrate separately. Let me start with this one. Because if we differentiate this, we are going to obtain this. Therefore, the solution to this problem is just what? The natural log of what? The absolute value of our denominator. That is what you should remember from elementary calculus. Therefore, let me bring this one separately. We have 5 over 4 multiplied by the integral of 4x plus 4 divided by 2x squared plus 4x plus 3 with respect to x. I told you this is the same thing. Already we have our constant 5 divided by 4 multiplied by the natural log of the absolute value of 2x squared plus 4x plus 3, right? So now let me take the second one and integrate it as well. We can factor out 2 from our denominator. So this is equal to 4 multiplied by the integral of 1 divided by 2 outside. Inside we have x squared plus 2x, right? Then plus 3 divided by 2 dx. And this 2 can come outside and it will divide 4. We have 2. So this is equal to 2 multiplied by the integral of 1 divided by x squared plus 2x plus 1, right? Plus 1 divided by 2. They're all the same thing because 1 plus 1 divided by 2 is the same thing as 3 divided by 2 dx. The first 3 times can be factorized, right? This is equal to 2 multiplied by the integral of 1 divided by x plus 1 all squared, right? That is the first 3 times. Then we have plus 1 divided by 2, which I can write as the square root of 1 divided by 2 all squared. For a reason, I'm going to show you why. So let me show you why I wrote 1 divided by 2 as the square root of 1 divided by 2 all squared. Remember that if you have the integral of 1 divided by x squared plus a squared, this is equal to, okay, with respect to x, right? This is equal to 1 divided by a, right? Multiplied by arctangent or tan inverse of what? X divided by a, then plus the constant of integration. So let us apply the same thing in integrating this function. So it will be equal to 2, which we have as constant. Then it will multiply the whole of this. What is 1 divided by a? It will be 1 divided by, this is our a, right? Because we have a squared. So it will be 1 divided by root of 1 divided by 2, right? Multiplied by arctangent, let me say arctan of what? X divided by a. But this time around we have x plus 1 as x. We have x plus 1 divided by a, and a is what? Square root of 1 divided by 2. We don't need to add plus c because we have the other part. But I can simplify this. We can introduce this 2 inside. This will become 2 divided by the square root of 1 divided by 2 multiplied by tan inverse of what? X plus 1 divided by the square root of 1 divided by 2, right? So this is what we have to the other integral, but we have our first solution. Therefore, we are going to take the first solution, which is this one, and subtract the second one. So let me just copy that. So this is the first part. We are going to subtract the second part. I'm just going to copy that as well. And hence, this is the solution to that problem. And don't forget to add the constant of integration, for which this constant belongs to the set of real numbers. Here is our last problem. We are going to integrate the function 1 divided by x multiplied by the square root of x squared minus x plus 1 with respect to x. Alright, first of all, I would like to get rid of this x right here. I only want to see square root of a function down here. And how can we do that? By substitution. So let x be equal to 1 divided by, let me use t, such that this t is equal to 1 divided by x, right? So we are coming back for this. Let us differentiate both sides of this equation. We have dx equal to negative 1 divided by t squared. So now let us back substitute. From here, you can see that 1 dx is the same thing as dx, right? And our dx is equal to negative 1 divided by t squared. Okay, we should have dt here. So we have the integral of negative 1 divided by t squared dt to the top. To the bottom, already we have declared x with 1 divided by t. So we have 1 divided by t for x, then multiply by the square root of x squared minus x plus 1. Square root of x squared, which is the same thing as 1 divided by t squared, minus x, that is minus 1 divided by t, then plus 1. Inside our square root right here, which is the radicand, I would like to factor out 1 divided by t squared. So this is equal to the integral of negative 1 divided by t squared dt divided by 1 divided by t multiplied by the square root of, I would like to factor out 1 divided by t squared. Then inside, from this term, we have 1 left, right? Take this, divide by what you have factored out, you have negative t, then plus 1 divided by that, you have t squared. We are moving. Then if you take the square root of 1 divided by t squared, you are going to obtain 1 divided by t. As it comes out, it will multiply this. So you have 1 divided by t squared. So this is equal to the integral of negative 1 divided by t squared dt divided by 1 divided by t squared, right? Multiply by the square root of, I can rearrange it as t squared minus t plus 1. From here, this will cancel this. So to the top, we only have negative dt, and we can bring the negative sign outside. So this is equal to negative the integral of dt, right? Divided by the square root of t squared minus t plus 1. This is what we have. Now let us make these two terms a complete squared. So this is equal to negative the integral of dt divided by the square root of t squared minus t. Coefficient of t is negative 1 divided by 2. You have negative 1 divided by 2. Square that, you have 1 divided by 4. Alright, sorry, here we have plus, not minus. We have plus 1, but since we have added this to neutralize it, we are going to subtract it. Everything is now balanced. This is equal to negative the integral of dt divided by the square root of, these first 3 terms can be written as t minus 1 divided by 2 all squared. T minus 1 divided by 2 all squared. Then if you simplify this, you're going to obtain 3 over 4. So we have plus 3 divided by 4. I would like to do another substitution right here. So let t minus 1 divided by 2 be equal to the square root of 3 divided by 4. Why I want to take square root? Because power of 2 will eliminate the square root. Then multiply by tangent of what? Theta. Let us differentiate both sides. If you differentiate t, you have dt. You differentiate 1 divided by 2, negative, you have 0. So to the other side, this remain constant, which is square root of 3 divided by 4 secant squared theta, because if you differentiate tan theta, you're going to obtain secant squared theta. Then we have d theta. Let us back substitute. Already we have dt here, which we are going to replace with the whole of this. So this is equal to negative the integral of the whole of this, square root of 3 divided by 4 secant squared theta d theta, divided by the square root of what? We have the whole of this squared, which is this squared. So we have 3 over 4 times squared theta, 3 over 4 times squared theta. Then we have the last term, which is 3 divided by 4. 3 divided by 4. Now, since we have 3 divided by 4 here, let us factor it. So this is equal to negative the integral of square root of 3 divided by 4 secant squared theta d theta, divided by the square root of 3 divided by 4 outside. In the bracket, we have tan squared theta plus 1, right? Tan squared theta plus 1 is nothing but secant squared theta. So let us replace this one with secant squared theta. So we have this to be equal to the integral of the square root of 3 divided by 4 secant squared theta d theta. We divided by square root of 3 divided by 4 multiplied by secant squared theta, because I told you tan squared theta plus 1 is secant squared theta. Now let us take the square root of the denominator. We have this to be equal to negative the integral of square root of 3 divided by 4 secant squared theta d theta, divided by square root of 3 divided by 4 remain square root of 3 divided by 4. Square root of secant squared theta will give us secant theta. So for cancellation, you can clearly see that this will cancel this, and secant theta will go into secant squared theta one time. So we only have secant theta d theta as our main function. So this is equal to negative integral of secant theta d theta. So how can we integrate secant theta? It is the same thing as what? Natural log of secant theta plus tan theta. But remember, we have a negative sign. So this is equal to negative natural log of the absolute value of secant theta plus tangent theta plus the constant of integration. We are done. But remember that our main function was in terms of x, not in terms of theta. So we have to back substitute. All right, coming back here, t minus 1 divided by 2 is equal to the square root of 3 divided by 4 tan theta. I remember that t is 1 over x, right? From here, let me see. Yeah, you can see it. T is 1 over x. So let me just copy this one and replace t with 1 divided by x. So here is where we're going to solve for theta and replace it back here to obtain our final solution. But remember that t is 1 divided by x, right? So we have 1 divided by x minus 1 divided by 2 equal to square root of 3 divided by 2, because square root of 3 remains square root of 3, but square root of 4 is 2. We have tangent theta. We can simplify the left hand side. We have 2 minus x, right, divided by 2x. And this is equal to square root of 3 divided by 2 tangent of theta. I can write square root of 3 divided by 2 as what? 3 divided by 2 root 3 for a reason. If we multiply the top and the bottom by root 3, this is what I mean. If you have square root of 3 divided by 2, multiply the top and the bottom by square root of 3. To the top you have square root of 9, which is 3. So this will give us 3 divided by 2 root 3. I'm doing this for a reason. You will see that very soon. So this is what? 2 minus x divided by 2x equal to 3 divided by 2 root 3 tangent of theta. So let us make tangent of theta the subject by multiplying both sides by the reciprocal of this, which is going to give us what? 2 root 3 divided by 3. So it's like we are going to multiply this by 2 root 3 divided by 3. We also have to do it here. 2 root 3 divided by 3. You can clearly see that this will cancel this will cancel this, right? Tangent theta equal to what? If you multiply the top here, you have what? 2 root 3 multiplied by 2 minus x divided by 3 times 2x, you have what? 6x. Or you can say that 3 multiplied by 2x, because I want to cancel something here. You can see that 2 will cancel 2, right? Tangent theta is equal to root 3. If you like, you can expand. I can say 2 root 3 minus root 3x divided by 3x. We're almost done. To find theta, we are going to take tan inverse of both sides. So theta is equal to arctangent or tan inverse of the whole of this. 2 root 3 minus root 3x divided by 3x. So this is what we need to replace for theta in our main solution, which is this one. So let me just copy this one and substitute. All right, this is our final solution. Let us substitute theta. Wherever we have theta, we are going to replace it with the right hand side of this equation. So finally, we have this to be equal to negative natural log of the absolute value of secant theta, but theta is what? Tan inverse of 2 root 3. We have 2 root 3 minus root 3x divided by 3x, right? Then plus tangent, but because we have theta to be equal to tan inverse, this tan and this will cancel, leaving only the function. So we're only going to write 2 root 3 minus root 3x divided by 3x, right? The absolute value is here, then plus the constant of integration, and we are done. This is just the solution to that problem. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.